Next, we want to be concentrating on the adding and subtracting of sides. We have got the examples that we have here. First one, we are having 4 root 3 plus 2 root 3. Here the radicals are the same and in their simplest form. Therefore, we just have to add the coefficients of the coefficients of the sides. So 4 plus 2 is going to give us 6. So our final answer is going to be 6 root 3. Take note, the items under the radicals are not supposed to be added. We only add the coefficients the same way we do when we are dealing with algebraic expressions or symbolic expressions. Here's our example 2. Got 7 root 5 minus 9 root 5. The radicals are the same and in their simplest form. Therefore, we just subtract the coefficients. 7 minus 9, we get a negative 2. Then our final answer becomes a negative 2 root 5. We've got our example 3, which is 3 root 2 minus 4 root 2 plus 2 root 2. And in this case, again, the radicals are the same and in their simplest form. So we go straight to applying BODMAS. From there, we simplifying the coefficients. We are having 3 plus 2 minus 4, which gives us a 1. So simplifying the coefficients, we are going to have a 1 multiplied by the said part, which is root 2, which gives us a root 2. Then going on to example 4, we are now having root 18 plus root 32. If we check, the radicals are not the same. So the first step is we have to express the sets in their simplest form. Our 18 is having a perfect square, which is a factor, which is 9. So it means 18 can be written as 9 times 2, because 9 is a perfect square. We go on to 32, we have a perfect square, which is 16. So 32 can be written as 16 times 2. So this says we can now reduce that square root of 9 is giving 3. So root 18 can be reduced to root 9 times 2, which reduces to 3 root 2. We apply the same procedure on our root 32 so that it reduces to 4 root 2. Now, we now have radicals which are the same. So, we can now add the coefficients, which is a 3 and a 4. Then we end up having our 7 root 2. We end up having our 7 root 2. We check in our example 5. We have root 216 minus 2 root 6. But we agree that the first step is to make sure that the sets are in their simplest form. So if you check root 216, it's not yet in its simplest form. 216 is having a factor which is a perfect square, which is 36. 36 times 6, we get 206. So instead of writing root 206, it reduces to root 36 times 6. But root 36, we know it's 6. So root 216 reduces to 6 root 6 minus 2 root 6. If we can now see, the radicals are now the same, therefore we can subtract the coefficients. So 6 minus 4, we end up getting 4. So our final answer becomes 4 root 6. In our example 6, we are having root 6 plus 10 root 7. And as you can see, the radicals are not the same and they are already in their simplest form. Therefore, the sets can't be simplified further. These are unlike terms. Therefore, it reduces to root 6 plus 10 root 7. We just maintain it like that. If we check our example 7, we are having root 50 plus root 75. So this 50 is having a perfect square, which is a factor. Likewise, 75 is having a perfect square, which is a factor. So the first step, we have to reduce these to their simplest form. 50 is having 25 as a factor. 75 is having 25 as a factor. So simplify 15 becomes square root of 25 times 2, and the square root of 75 becomes square root of 25 times 3. Then square root of 25 is 5. So we are having 5 root 2 plus 5 root 3. Now the radicands are not the same after simplifying to their simplest form. Therefore, the surds cannot be simplified further. So our final answer becomes 5 root 2 plus 5 root 3. Then we have the last example here, which we call a special case. If we check, we have 5 times square root of 2 plus 5 times the cube root of 2. Here the radicands are the same because the radicands we are referring to this number under the root sign. They are the same, but and in their simplest form, but the indices are not the same. Here is cube root, here is square root. Therefore, this can be simplified further. If you check when we introduced the chapter, we said for us to have like surds, we are supposed to have the same radicands as well as the same indices. Thank you.